All right, this is lesson 1.1. This is your first at-home video. This is what is chemistry, and of course a course overview.
And then we're going to briefly review kind of the syllabus of the course, like what all are we going to be covering this year, and what do we expect you to get out of it.
Yeah, so there's also, of course, a brief history of chemistry as well.
So back in the Dark Ages, there was no science of any kind, no technology other than really primitive things, but the origins of chemistry have their root in these people called alchemists.
Yeah.
So they were medieval, and we put the word chemist in quotes because there wasn't actually such a thing as a chemist back then. But their whole goal was to find ways of turning less valuable materials like lead and things into gold.
And also urine, because urine was yellow, so they thought there might be gold in it. Pictured below might be what's considered the philosopher's stone, which is what they were looking for to make this how happen.
Yeah, somehow this would...
would magically make it happen. So anyway, the actual origin of the word chemistry came out of alchemy. The ancient name of Egypt was chem, or however they'd actually pronounce that. The Greek word for the art of transformation was alchemia, and this later became alchemy in English, and then the word chemistry derives from this word.
So when chemistry got itself organized to a science, they said, what should we call it? And that was the word they settled on because it has roots. And actually the alchemists, when later scholars went back and read over their work, they never did find out how to turn lead into gold, which we know is chemically not possible.
But they did find some other useful stuff.
Discovered a lot of other reactions and processes that chemists were able to begin to use.
No. So chemistry is defined as the study of matter and the changes it undergoes. So that basically means that's everything. Everything's made of matter. Chemistry studies everything.
So, we listed below a laundry list of just kind of brainstorm of and things that chemists might be involved in. So improving materials, developing new materials, including medicines, including
your fancy electronics that you like
devices,
to play with all day
screens,
long.
And then improving chemical processes. How do we get more product out of a reaction? How do we make more product with less cost, less energy input? And how does the environment work? Because we know that living things are chemical factories in a sense, and they process chemicals and cause chemical reactions to happen. And on a more larger scale, the oceans and the atmosphere have chemical cycles and changes. So chemists can look at any of that. It's a very, very broad field. And at the bottom, basically chemists are going to be involved in it in some way if it involves matter. And like Mr. Hunter said, matter is everything. So this is a fundamental science, and it's highly important.
All right, there are many branches of chemistry, since as we listed before, all the things we can do. We're going to list just a few of them for you down here below. Granted, there are many, many more. First type that can come to mind is the organic chemist, and that's anything that studies the chemistry of carbon. Yes, one element gets its entire branch.
Okay, and then inorganic is the chemistry of everything but carbon. It's not really fair, is
No.
it? But carbon is such a...
universally...
yeah, it's in everything, and it makes up so many different compounds. It's got its own branch of chemistry.
We then have analytical, which is used to identify what and how much of things are in there. It's a broad definition like the rest of these, but it's for people who like to count beans, basically.
What's in this little sample of goo we scraped off this perpetrator's, the suspect's shoe? Nuclear chemistry would be the study of atomic nuclei and their changes.
Polymer chemistry is basically pulling out one type of organic chemistry and making it its own branch. So again, you can really refine what chemists can do to a very narrow topic.
Okay, biochemistry, as you can tell from the name, is looking at the chemical processes of life. How does photosynthesis work? How do the chemical reactions inside of a living thing take place?
Then we have physical chemistry, which is the physical movements and properties of substances.
More recently, with the advent of some of the technology we have now, is nanochemistry, where we can study the behavior of, kind of individual atoms and molecules and arrange particles on
or nanoclusters and stuff like that.
Almost manipulating single atoms or tiny clusters of atoms to get them to do what you want.
And we also have chemical engineering as the last thing. Again, that one's basically a chemist who likes to build stuff. It's you improve of chemical processes, usually for industrial things. But again, we just listed a few things
And
that chemists
It's
do.
a very, very broad field, and there's lots of ways you can go if you decide to pursue that.
Yep. All right, chemistry is important in medicine, manufacturing, environmental science, and many other fields that involve matter.
So things that you're going to study this year, if we break it down into kind of 4 major categories, we will start the year off looking at the properties and classification of matter.
The atomic structure and the periodic table.
And then we will spend a good chunk of the second half of the year looking at the mole, and not the furry little ground dweller. You'll learn what a chemical mole is, and chemical bonding, how atoms hook up with each other and make compounds.
And then lastly, the chemical relationships and reactions. Would you actually kind of get into what chemistry is?
And so those 4 topics will occupy us for the next 9 months in class.
Yep.
So these questions, we called them reflection questions as opposed to post-video questions. Same idea.
I guess we weren't on the ball yet.
So these would be your PVQs. So push the pause button and answer them in the space at the bottom of your notes.